Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to demonstrate how to calculate the work done by a series of forces when some of them are not directly parallel to the motion. So in this example we've got this object, doesn't matter what it is, acted upon by the four forces I've got shown. F1 acting 20 degrees with the horizontal here, F2 acting 60 degrees with the horizontal, F3 to the left, F4 straight up. And we're going to imagine that this particle undergoes the following displacement. It starts here at what I'm going to call position 1, moves over to position 2 over here, a distance I'm going to call D. So that's going to be this distance in this problem. Alright, what we're going to do is we're going to try to calculate the net work done on this object as it moves from position 1 to position 2. So remember, work is force times distance, but only forces in the direction of motion do work. I'm going to take these one at a time, starting with F1. Now F1 can be broken into components that look maybe like, whoops, I'm going to draw these in red, maybe something like this. And this. This is the component of F1 that is parallel to the displacement D. This is the component of F1 that is perpendicular to D. And these have arrows as well. The important thing to recognize, this is the one doing work, and this one doesn't do any work because only forces parallel to the direction of motion do work. So the work done by F1 as this object moves from 1 to 2 is equal to F1 cosine 20 times D. The F1 cosine 20 gives me the component of F1, the component of this force vector that's in the direction of displacement. The work term is positive because that component points in the direction of motion. So this term, F1 cosine 20 times D, represents the work done by force 1 as this particle right here moves from 1 to 2. All right, let's talk about force 2 here. Right. Force 2 can also be broken into components. If I were to draw them, right, force 2 has I guess what I would call an X component. That looks about, whoops, I'll go back and draw that in red. To about there. And a Y component looks about like this. I gotta go back and do a little erasing. Drew that a little long. Alright. There's F2 in the direction of D. F2 perpendicular to D. So F2, if we think about it in terms of components, it has a component parallel to D, a component that makes a right angle to D. When we calculate the work done by force 2, we want the parallel component. This angle is 60 degrees. That makes this component equal to F2 cosine 60. That makes the work term equal to F2 cosine 60 times D. That work term also is positive because that force component is in the direction of motion. Right. F3, work done by F3. Well, F3 we don't really have to worry about components. It's parallel to the motion, but F3 points to the left and this object is moving to the right. That makes that work term negative. Then we're going to have just minus F3 times D. F4. F4 makes a right angle to the motion the entire time, so F4 doesn't do any work. I'll go ahead and just put 0. I'm not interested in numerical values in this example. All I was trying to do is to demonstrate how to take forces, break them into components, decide which component is doing work when you're trying to do a work calculation. Another important part of this video is recognizing forces that make a right angle to the velocity. Again, this object's moving to the right. Forces that make a right angle to the velocity or the displacement don't do any work. Forces in the opposite direction of motion do negative work. Hope this video helped demonstrate how to calculate those work terms. Have a great day.